These are the College Algebra Lesson 26 activities. We're going to graph each rational function, state the domain, holes, vertical asymptote, horizontal asymptote, zeros, and y-intercept. And then finally, plot some points and the graph. Okay, so domain is all x values except for any that would make the denominator 0. So the denominator would be 0 at -2 and -3. So the domain is the set of all x's such that x is not -2 or -3. So both of those are excluded from the domain. It says reduce and find any holes. So to reduce this function, I would cancel out the x plus 2's, and I end up with 1 over x plus 3. Now, holes happen at x values that make both the denominator and the numerator 0. So my hole is going to be at x equals -2. And then to find the y value of the hole, I'm going to plug this -2 into the reduced version of the function. So I'm going to have y equals 1 over -2 plus 3, which is 1 over 1 or 1. So my hole is at -2, 1. Okay, vertical asymptotes are places that make the denominator 0 but not the numerator. So that would happen when x equals -3. Horizontal asymptotes, to find those, you compare the degree of the numerator to the degree of the denominator. So in this case, the degree of my numerator is 1 because it's x to the first. The degree of my denominator is 2 because if you multiplied these two factors together, you'd have an x squared. So the highest power on x would be 2. When the degree of the numerator is less than the degree of the denominator, your horizontal asymptote is the x-axis. Always. When the degree of the numerator is smaller than the degree of the denominator, the horizontal asymptote is the x-axis, aka y equals 0. The y-intercept happens when x is 0. So I'm going to make all my x's 0 in the original function. And that gives me 2 over 6 or 1 over 3. X-intercepts happen when your numerator equals 0. And that would happen when x is -2, except x cannot equal -2. That is an excluded value from the domain. So this is actually not the x-intercept, not in the domain. Okay, I'm going to do symmetry after I draw a graph because it might be easy. If it's neither, it'll be pretty easy to tell. So I'm going to save symmetry until later. Let's plot the things I know. I have a hole at -2, 1. So I'm going to put an open circle there. I have a vertical asymptote at -3. Put a dashed line there. I have a horizontal asymptote at 0, or the x-axis. And a y-intercept of 1/3. That's about right there. And then I need some more points. Okay, so to the right of my vertical asymptote, I have enough to know what this looks like because I know if I try to go, this hole is above this point here. So as I go right, I'm moving down. And if I continue moving to the right, the graph is going to continue to go down, but it's going to approach that horizontal asymptote. And if I try to go left and continue moving up, it's going to be stopped by this asymptote, so it'll approach that. So the whole right part of the graph, I have enough to be able to draw. Go ahead and put that in. And then to the left side of my vertical asymptote, I don't know if I'm going to draw this swoosh or this swoosh. So I'm going to plot 1 point, maybe -5, get a value. 1 over -5 plus 3 is -1/2. So -5, -1/2, I have a point there. And then if I move to the right, it's going to go down to my asymptote. And I move to the right, and it's going to go up to my horizontal asymptote. Finally, let's just address the symmetry. Taking a look at what we've plotted, it does not have y-axis symmetry nor origin symmetry. So this is a neither. Number 2, r of x equals x plus 1 over x times x plus 4. So my domain is all real numbers except any that would make this denominator 0. So I can't have x be 0 and I can't have x be negative 4. So I'll say the set of all x's such that x does not equal 0 or negative 4. Reduce, nothing reduces. There are no common factors on the top and the bottom, so we have no holes. Vertical asymptotes happen when the denominator is 0, so either when x equals 0 or x plus 4 equals 0. So x equals 0 or x equals negative 4. Horizontal asymptotes depend on the relative size of the degrees of the numerator and denominator. If I multiply these together, my numerator is x plus 1, and I'm going to multiply the two factors of the denominator together, and I get x squared plus 4x. That means the degree of my numerator is 1 and the degree of my denominator is 2. The degree of the numerator is smaller than that of the denominator, so my horizontal asymptote is at y equals 0, which is the x-axis. To find a y-intercept, you plug 0 in for x. So we would have x plus 1, where 0 plus 1 over 0 squared plus 4 times 0, which is 1 over 0, which is undefined. Okay, so we have no y-intercept. To find x-intercepts, we set the numerator equal to 0, and we get x equals negative 1. And then to check for symmetry, you replace all your x's with negative x's. So r of negative x would be negative x plus 1 over negative x squared plus 4 times negative x, which is negative x plus 1 over x squared minus 4x. This function is not exactly the same as the original, nor is it exactly the opposite of the original because I didn't change every single sign. So this has neither kind of symmetry. All right, let's draw all the things we know so far, and then we will add some points as needed. So I have vertical asymptotes at x equals 0, that's the y-axis, and at x equals negative 4. And I have a horizontal asymptote at y equals 0. And no y-intercept, but I have an x-intercept at negative 1. Right there. Okay, so I want to add points between and beyond any vertical asymptote and or x-intercept. So I think I'm going to add for x's. I'm working my way left to right, and I know nothing about what happens over here before the first vertical asymptote. So I'm going to add negative 5 or negative 10 or anything in between. Let's go with negative 7. Next, I need a point after the first vertical asymptote, but before this x-intercept. So something between negative 4 and negative 1, maybe negative 3. Okay, then I need something between the x-intercept and the next vertical asymptote. So something between negative 1 and 0, like negative 1/2. And finally, I need an x value after the last vertical asymptote. So something after x equals 0, maybe x equals 3. Okay, so I had a calculator calculate each of these for me. I get negative 0.29. And then for negative 3, I have 0.67. Negative 1/2, I have negative 0.29 again. And then 3, I get 0.19. Maybe we'll just call that 0.2. Okay, so I'm going to plot these points. I have negative 7, negative 0.29. So just barely negative there. And then negative 3, about 2/3, almost 1. And then -1/2, -0.29, so barely negative. And then 3.2, barely positive. All right, so now I should be able to use those points that I just graphed and the asymptotes as guides to draw the rest of my graph. So let's start between the two asymptotes. I've got the x-intercept, and then it has to connect, moving to the left, we have to connect to this next point, and I also know that this graph has to approach the vertical asymptote. And so I know it's going up, so I think it's going to continue to go up and approach that asymptote. Like that. And then moving to the right from this x-intercept, it has to go down to get to the next point. And then I also know that it has to approach this asymptote, so it's going to have to continue down and approach that asymptote. So it looks something like that. Okay, now to the right of the vertical asymptote at 0, I only have 1 point. I could get more if I wanted, but I do know that my graph has to approach the horizontal asymptote as I head out towards the right, and it has to approach the vertical asymptote without crossing the x-axis because I only have this one x-intercept. So it definitely does not go down like that, or else it would cross the x-axis again. So the graph has to go up and approach the vertical asymptote and come down towards the horizontal asymptote to the right. Like that. And then I have a similar thing happens over here with this point. I know I can't cross the x-axis, so in order to approach this vertical asymptote, we have to go down. We can't go up and approach it because we'd have to cross the x-axis, and I only have this one x-intercept. So this has to go down, and I know that my end behavior to the left is to approach the horizontal asymptote, so it's going to go up to the left and approach the x-axis, and down to the right and approach the vertical asymptote. Something like that.